All right, moving on to number 33. Like I said in the previous video, I might do these a little bit faster than the previous ones because I've kind of walked through a little bit more slowly how to do each of those kind of step by step and what to plug and where. So I will do this a little bit quicker because again, this is just that constant practice of going back and forth between, right, they're giving you a certain amount of information in the problem. How can you take that, manipulate it to get something else, to get what you need or what it's asking you for? So 33 is saying the concentration of acetic acid, which has a pKa of 4.75, in vinegar is about 1.0 molar. By the way, household white vinegar is just diluted acetic acid. With this information, what do you predict the pH of vinegar to be? So, right, it gave us a pKa. It wants us to find the pH. In order to get the pH, we need to have the H plus concentration. So how do we get the H plus concentration? Well, we can use the Ka formula, right? Do an ice table, plug into the Ka formula, right? But in order to do those, or at least how we practice them so far, we need to at least know the Ka. Well, good thing it gave us the pKa, because you would look at your little formula sheet, and again, seeing that you can get the Ka by doing 10 to the negative pKa. So, because what I'm going to aim for is I want to actually do a Ka, getting out of frame here. I'm going to want to actually plug into this formula here, which will always equal in our problems. This will be like our x squared divided by HA minus x. And then if rule of 100 applies, we'll be able to like get rid of this x. But we need the Ka in order to do this because I need to get this x because x is representing my H plus concentration, which I need to plug into the pH formula to get the pH that it's asking for in the problem. So I'm going to find the Ka by doing 10 to the negative pKa. So that's going to be 10 to the negative 4.75. And again, how many sig figs do we have? Right, this was a negative log that we took. So our sig figs are after the decimal because that 4 is just a placeholder for base 10. So in our calculator, we are going to do 10 to the minus 4.75. We get 2 sig figs only. This has to round to a Ka of 1.8 times 10 to the negative fifth. Oh, and perfect. That is the Ka of acetic acid. And that's the same one that they were using in previous problems too, if you've been kind of following along. So now we have exactly what we need to plug into this formula here. So now I know that, right, this is really the Ka that I'm plugging in over here. So I have 1.8 times 10 to the negative fifth equals x squared divided by, let's see if I can actually eliminate that minus x by checking the rule of 100. Obviously we're going to be able to, but let's just look at it. It told us in the problem the concentration was 1 molar, and we're dividing it by that Ka. Okay, if you don't believe this is more than 100, if you can't see that, double check it in your calculator to make sure, but yes, definitely qualifies. I'm getting rid of that minus x. I'm too lazy to do the quadratic, so I'm going to be dividing this by 1.0 molar, which it gave us in the problem. So I'm going to solve for x squared, which I'm just going to do this times the 1, which just means this. Take the square root of both sides. Our x equals, remember, 2 sig figs. Those don't count, they're leading zeros. 4.2. Okay, that is my x, which means that is my H plus concentration, because that's how we got this stuff over here. So now to get the pH, I just got to do, let's put that back in there, right? That was x, that was H plus, same thing. So the pH is whatever the negative log of our H plus concentration is. Well, we just found our H plus concentration here. We do negative log. We get, I just lost my test. So I don't know if you can see my calculator here, but we technically get 2 sig figs here because we've had 2 sig figs the entire time in this problem. We had 2 sig figs here, right? We have 2 here in the Ka, all this stuff. So we should technically get 2 numbers after the decimal if this were to be correct. So we have to get the right, 2 doesn't count because that's a placeholder for base 10 movement. This should be 2.38 for our pH. Our answer choices on the test, though, are not to correct sig figs. This guy keeps on doing this a lot. We should email him, guys. Closest one we're getting is 2.4, which is the closest one to this one. It's not right, though. It should be 2.38. But we're right. They're wrong. But either way, right, that's the correct answer. So if you got that right, you're doing it right. Okay, let's move on to 34. Boric acid frequently is used as an eye wash to treat eye infections. The pH of a 0.050 molar solution of boric acid is 5.28. What is the value of the boric acid ionization constant, Ka? Oh, this is different. It's wanting us to actually solve for Ka. So far, we've known Ka, and we've actually had to solve for the other stuff. So how are we going to do this one? What did it give us in the problem? I need to rearrange this one. Don't keep on getting this out of frame. Okay, in the problem, again, follow along with your own, but it told us what the pH of that boric acid was. Nope. The pH was 5.28. Should probably rewrite that nicer. The pH was 5.28. 2 sig figs. And it told us that the concentration, gave us the concentration right in there. Initial concentration that would be was 0.050 molar. Okay. So it wants us to find Ka. So like it's not giving us Ka this time because we know that our Ka is going to be the H plus concentration, A minus concentration, Ha concentration. So if you want to, you can look up, well, you guys should know the boric acid formula because it's an oxy acid. That's hydrogen plus borate, so it'll be HbO3. You can do the HbO3 plus H2O, dissolving into the borate ion and the H plus, and doing the big ice table for it. But either way, we know that we're always going to come up with these numbers here, right? Still, right? We do the ice table. This would always be x. That's always x. That's x squared divided by whatever HA minus x is. But it wants us to find Ka this time. It doesn't give us Ka, which means we're going to have to know and work backwards right now to get what x is. But the key to this one is like, we know that our x in these equilibrium expressions always equals our H plus concentration, right? And we can get an H plus concentration. If you look at our formula sheet, we can figure out an H plus concentration if we have a pH, because we can do 10 to the minus pH to get the H plus concentration. Well, it gave us the pH in the problem at 5.28. So I can plug in 5.28 up here, do 10 to the minus 5.28. My H plus concentration is, how many sig figs do we get? 2. So this is a concentration, so it all counts for sig figs. We have 5.2 times 10 to the negative 6 for our H plus concentration, which, as we know, right, always equals x. So if I come back to this formula up here, right, I need to solve for Ka. So we had to work backwards right now to find x. So we know what x is now. X is going to be squared. So we're going to do the 5.2 times 10 to the negative 6 squared, all divided by the concentration it gave us was 0.50 minus whatever this x is, which we just found to be 5.2 times 10 to the negative 6. You're going to have to put parentheses around that when you put that on your calculator, or it is not going to like you, right? What your calculator will do is it'll first subtract those two. So you would have done this, and then it's going to, like in the division part, in the quotient part, it's going to do this minus this. And then if you don't put this in parentheses, it'll times this whole thing by times 10 to the negative 6, which you don't want. So make sure to put that in parentheses. And also, if you're doing this in your calculator, I'd recommend putting all this in parentheses if you're actually doing this all in one shot, to make sure that you're actually dividing by, right, everything that's down here in this denominator, right? But we go through, I don't want to waste time typing this into the calculator because I've already checked it before, that it's a little bit tedious to do that. This would actually give us option B, which is 5.51 times 10 to the negative 10th. I'm only allowed to have 2 sig figs though. So what we should have really got though was really just, our answer should have been 5.5 times 10 to the negative 10th for our Ka, because we had to stay true to sig figs, right? This is, right, 2 sig figs here. The answer choice gave us an extra number, which doesn't, that's not right. This is the actual answer to correct sig figs here, okay? So 35 says a 0.100 molar solution of a monoprotic weak acid. Monoprotic just means when it dissociates or dissolves, it just releases 1H plus, which is good because those are the kind of acids we've been dealing with. It has a pH of, so we have some weak acid. This is the concentration of some weak acid. And it tells us the pH of it is 3.00. So this is 1, 2, 3 sig figs, but this one gives us 2 sig figs. So we're going to have to keep track of what equation we're plugging in where, but right now we could possibly be limited to 2 sig figs depending on what we plug in where. It's asking, what is the pKa of this acid? So we can't get a pKa until we know the Ka, because the pKa is the negative logarithm, whatever your Ka is. Oops, it's not, yeah, it's Ka at equilibrium technically. So we have to know what Ka is before we can plug it into the pKa formula. So this is going to be just like this previous problem up here, where it's like, okay, it gave us the pH. So with the pH, I can get the H plus concentration. H plus concentration will always be X. Then I can actually plug X into this formula here to get the Ka. Once I have the Ka, I can do the negative log of that Ka to get the pKa. So let's actually kind of do this all then. So I'm going to get, I need to get my Ka, which will always be, right, we can do the ice table and bother with it. In this case, it's always going to be X squared divided by that concentration of that acid minus that change in X. And this concentration is kind of high. And it did say it's a weak acid, so it's almost safe to assume right now that we could probably eliminate this minus X. But let's not, just in case, to see if we get the same thing. So let's actually kind of work this. We need to know right now what we have to get for X plus, which will be, we know what that X is, will always be our H plus concentration. And we know that we can get the H plus concentration by doing 10 to the minus pH. Gave us the pH at 3. So that's going to be 1.0 times 10 to the negative. No, it's not. It's going to be, yeah, 1.0 times 10 to the negative third. 0.001 is the same thing. It's 1.0 times 10 to the negative third for our H plus concentration, which is our X. So now we're going to plug that directly in here. So our Ka, and we need to get the Ka because we can't get the pKa until we get the Ka, is going to be 1.0 times 10 to the negative third squared, all divided by 1.100 minus that's going to be our Ka. So I'm going to pause the video real quick. I'm going to do this the long way, get the answer, plug it in, get the thing, and see if we could have eliminated the minus X real quick. I don't want to take up too much time on this video, so I'm just going to pause it real quick, and I'm just going to double check that we could actually eliminate this minus X here. But, I mean, 0.1, I mean, it's not the most concentrated, but it's pretty concentrated, and it's telling us it's a weak acid, so we can almost assume we could probably eliminate that, but I'm just going to double check to make sure that we don't have to, because this would just be a really, really ugly thing to get the, to do the quadratic with. 1 second. Okay, back to recording. I'm going to eliminate this whole sucker down here. We don't have to do that. So our Ka is going to equal 1.0 times 10 to the negative third squared, all divided by this. our Ka is 1.0. Yeah, because I'm limited to 2 sig figs right now. 1.0 times 10 to the negative fifth is my Ka. And now I can, well, if we do the negative log of this, you guys can probably see that it's going to be 5. But now that we have the Ka, we're going to plug it into the pKa formula. Am I out of frame again? Okay, the pKa. Sorry, I'm at the bottom of the paper, and I'm like sitting far back in the chair, and it's hard to keep this in frame. Okay. Got this as the Ka, right? We can see that the pKa is going to be 5. Technically, it should be 5.00, but let's just, I'll show you how to do it the long way, right? pKa, you got to do the negative log of Ka, so we're going to do the negative log of this number. You're going to plug this into your calculator. It's going to tell you 5, and we get 2 sig figs, because a pKa, we just did a negative log, so that initial number before the decimal is a base 10 holder, so that 5 really doesn't count. So we get 2 sig figs after the decimal. I don't know if you guys could hear me, because this thing was like tweaking out, and like the camera was like juddering, and so I don't know if you guys heard me. Let me kind of start over real quick. I think you guys were with me when I went over here, found the Ka. You can tell by looking at this that if you do the negative log, it's going to be 5. But if you don't believe me, just go ahead and plug it into the pKa equation. Negative log of 1.0 times 10 to the fifth. This 5 that we get when you type it in your calculator, that 5 is the placeholder for that base 10 movement. So we still get 2 sig figs after the decimal, because this number has 2 sig figs. So our pKa is going to be 5.00. So yes, that is going to be a weak acid, because we have to have a pKa lower than 1 to be a strong acid. Moving on to, what number was that? We're on 36 now. Okay. This one was kind of getting repetitive at this point, because we're doing these all the same way. The acidic ingredient in vinegar is acetic acid. The pH of vinegar is around 2.4, so we get 1 sig fig. And the molar concentration of acetic acid in vinegar is around 0.85 molar. Based on this information, determine the value of the acid ionization constant, Ka, for acetic acid. So what do we pull from the problem? We pull from the problem that the pH is 2.4, and that the concentration, so my initial concentration here of that acid is 0.85 molar. And it wants us to find the Ka. Well, what's the Ka always going to be? It's always going to be x squared minus this. Acetic acid, well, it's pretty much going to have us work backwards and come up with that number that we always get, that's like 1 point something times 10 to the negative fifth. Acetic acid is weak enough for that rule of 100 is always going to work, especially when we have a concentration like this. Like if you're anywhere kind of like near 1-ish, like even like, I mean, if you have like a concentration that's like 1 times like 10 to the negative second third, that's a really small concentration. But right, like this is almost close to 1 molar. We have like, you know, almost a whole mole per liter. That's pretty concentrated, especially for a weak acid. So we're going to be able to eliminate this minus x eventually. So this is just like, I mean, we're on kind of repeat from what we did in the other sections, but we can't do this one until we know x, and x is always going to be our H plus concentration. Well, how do we get our H plus concentration? Well, we get our H plus concentration by doing 10 to the minus pH. So if I do 10 to the minus 2.4, that's going to give us an H plus concentration of, we get 1 sig fig. That's going to be 4 times 10 to the negative 3. 4 times 10 to the negative third power. Here's that in my calculator. 0.004. That's where I'm getting that number from. That's our x. So that's what we're going to plug in up here. So our Ka is going to be 4 times 10 to the negative third squared divided by that initial concentration 0.85, because I eliminated the minus x. Let's actually do this. 4 times 10 to the negative third. Oops. Whoops, I accidentally divided it again. 4 times 10 to the negative third. Our Ka is going to be 1 point, whoops, it's not. Yep, 1 point. Okay, this where it gets a little tricky because we get 1 sig fig here. So if we were doing this, so let me type in what the calculator is showing us. 1.88 times 10 to the negative fifth. The answer choice, it wants us to select as 1.9 times 10 to the negative fifth. That's not even close to what we're at. But based on what they gave us in the problem, and again, maybe one of us should email this guy, we were given 1 sig fig only. So when we even solved for our H plus concentration, we were limited to 2 sig figs. What they were doing in this problem is just kind of assuming that you had 2, because whoever made this forgot that only sig figs after the decimal count for pH. They were counting this whole thing as sig figs for the problem. We're limited to 1. So like technically, like the answer on the key, because they're assuming we get 2 sig figs, they're saying 1.9 times 10 to the negative fifth for Ka. But how we would have to, why did I put parentheses instead of a quote? What we would have to put for this problem, if we were doing it correctly to 1 sig fig, we would have to say that was 2 times 10 to the negative fifth for our Ka value of acetic acid, which is accurate-ish for what it is. It's like around 1.8 something to more sig figs than that, or than we can give here. But this should be the answer, but the answer choice you were selecting is D on that test. Okay, 37. Okay. 3 acids found in foods are lactic acid in milk products, oxalic acid in rhubarb, and malic acid in apples. The pKa values are also lactic acid 3.88, oxalic acid 1.23, and malic acid 3.40. Which list has these acids in order of decreasing acid strength? So decreasing acid strength means it wants us to rank the strongest to the weakest. This is an easy problem here because it gave us the pKa values. So we know that the higher the Ka, the lower the pKa, and the stronger the acid. So we need the lowest pKa to rank from strongest to weakest. So looking at this list, right, which of these numbers, 3.88, 1.23, and 3.40, which of them is the smallest? Oh, the 1.23, so that's the strongest acid, followed by the 3.40. That's the second strongest. The largest pKa given is the 3.88, so the largest pKa would be the weakest acid, so hence lactic acid there is the weakest, because we did have to rank them in order from strongest to weakest. That is why our answer choice is C for 37. Number 38. Last one for this video. Use the following acid ionization constants to identify the correct decreasing order of base strengths. Okay, I don't know if you guys can see this, but like every time I move, my screen is like freezing, and I don't even know if you guys can see me right now. Let me pause this and let it like actually catch up so I can start this again. It doesn't start jittering around. Hold on. Okay, I think it's fixed now. Okay, so 38, last one. Use the following acid ionization constants to identify the correct decreasing order of base strengths. So we have to remember back in either class or one of the first videos I posted for this answer key here, but decreasing base strength. So it wants us to kind of rank these from strongest base to weakest base. Well, if you look at these, if it gave us the Ka, these things are talking about an acid. So then how is like a base associated with an acid? Well, that acid will make a conjugate base. And like we learned before, the stronger the acid, the weaker its conjugate base. So basically what it wants us to do is, I'm going to kind of write over this in a different color. It wants us to kind of rank this from weakest acid to strongest acid. Is what it wants us to do, basically. So we had to do a little bit of mental gymnastics there to get that connection that it was trying to make there. So let's look at the problem. It gave us the Ka's of everything, and we know that we want the bigger Ka to be the stronger acid. So the one with the biggest Ka will technically be last in this list because it wants us to rank them from weakest to strongest acid. So let's look at the Ka's here. Which of these are the bigger number? Hopefully you guys can see that it's this one. So this is like my strongest one. So what I'm first gonna do is kind of rank them strongest to weakest. That's the strongest, that's the second strongest, that's the second weakest. Again, just look at the Ka values here. This is the biggest value of them all, followed by this one, followed by this one. So HF is the strongest acid, should be the last in the list because it wanted us to rank them from weakest to strongest. And well, it technically wants us to rank their base. So it's like HF, who's its conjugate base? Well, HF breaks up into H plus and F minus. Who does HNO2 break up into? That's going to break up into NO2. HCN is going to break up into CN minus. Oops, I forgot my minus on here. So, right, I used the Ka to find out who's the strongest to weakest. Got them ranked that way. It wants us to rank their bases, though. So then we have to, like, figure out the conjugate base and rank them accordingly, hence why our answer is A for this one. So what I might do here is look at, I'll kind of pick one problem from the next section that deals with KB and PKB. So it's like we're doing like the same thing that we just did with these. It's like sometimes it gives us, like in this one, it gives us a hydroxide ion concentration. So we can use that, right, to get a POH and then get the pH from that one. Maybe I'll just make a quick video, just like kind of quickly walking through how to do these. So that maybe like this can be ones that you guys practice. Because if you guys rely too much on me just walking through it step by step, you guys sometimes don't get that practice. The KB is a good section though, because sometimes you have that extra step of first doing it all with your bases and then having to work backwards to get your H plus. So let me make another video kind of just quickly going through and giving you hints on how to do these. So that hopefully you guys can try to attempt to do these on your own. And then, yeah, the rest of these, I think you guys would be able to do, which would be kind of good practice there. Yeah, I'm going to make another video real quick, kind of giving you some hints on all this stuff. So this ends the Ka, K, PKA, H plus, all that stuff. Let me go through and post something else real quick for 39 through maybe 50-ish.